In this video, we will begin the second chapter of the course, and I will argue that this chapter focuses on line segments. So I'm going to start off this chapter by drawing a nice picture of a line segment. And in fact, I'm going to draw it on a coordinate plane. So hopefully you can tell that this is a line segment and not a line, because I've replaced the arrowheads with endpoints. So that's really the big difference between a line and a line segment. It doesn't go on forever. We have these endpoints, and in fact, we generally label our endpoints. Because if I know the labels of my endpoints, I can identify this line segment. This is line segment AB. And if I can draw another one, let's say the endpoints are C and D. So this one is line segment AB, and this one is line segment CD. So when we have line segments, it's nice to identify the endpoints so we can talk about the line segment, especially when there are more than one line segment. Okay, so when you look at a line segment, okay, so let's focus on line segment AB. Well, or if you prefer, you can focus on line segment CD. It doesn't matter. When you look at a line segment, I really want you to ask yourself many questions. What do you want to know about this line segment? Imagine this line segment's your friend. What do you want to know about this line segment? I know it sounds weird, but that's really what we're going to do for the first half of this chapter. You have questions about the line segment, and we want to know how to find them. Okay, so write down a set of items that you want to find out about this line segment, or properties about this line segment. Okay, so you can pause the video, but I'm going to just keep going. So hopefully you wrote down some of the things that I'm about to write. So the first thing, when I see line segment AB, I'm very curious and I want to know what the slope of the line segment is. What is the slope of line segment AB? Now, if you remember from last year, you have the slope formula to help you find out what the slope of the line segment is. So this question we can actually answer rather easily. I can use any 2 points on this line segment, doesn't have to be the endpoints, and then punch it into the slope formula, find the rise, find the run, and the slope is rise over run. Okay, so that's the first thing I think of when I see the line segment, because we work with slope for a pretty long time in grade 9. Okay, the second item, or the second thing that comes to mind when I see a line segment, I get really curious and I ask myself, what is the length of this line segment? How long is it? Now, we don't know how to find it yet, but we will later on in this chapter. So hopefully you wrote that down. So I want to know the slope of the line segment. I want to find the length of the line segment. Now, the third item you might not have thought of, but I want to find the midpoint of the line segment. Okay, what is the midpoint of the line segment? Well, the midpoint is about right here. How do I know that's the midpoint of a line segment? Because the midpoint is equidistant to the 2 endpoints of that line segment. So there you go. I've shown that from the midpoint to B and from the midpoint to A, it's the same distance. And of course, the midpoint of AB has to be on line segment AB. So that's what it means to be the midpoint. Now the question is, how do we find the midpoint of a line segment? How do we find the point on the line segment which is equidistant to the 2 endpoints that make up that line segment? And that's what we're going to do today. So before we actually find the midpoint of a line segment, we want to talk about how to find the midpoint between 2 numbers. Okay, so let's simplify the question before we tackle the big one. So what number is exactly halfway between 1 and 3? Now that one is pretty straightforward. So hopefully you can just imagine the numbers 1 and 3 and you'll say 2 is halfway between 1 and 3. What is a number that is exactly halfway between 4 and 8? Hopefully give it some thought and you'll say 6. Now this one's a little trickier. What is exactly halfway between 5 and 10? So think about it. This one's a little trickier because it's not a whole number. It's 7.5. Okay, so I don't know if you had a strategy there, but what did you do? Hopefully you did some algebra to find the number that is halfway between each pair of numbers. Okay, so what I did was I actually found the average, because if you average 1 and 3, you'll find what's halfway in between. If you average 4 and 8, you'll get 6. If you average 5 and 10, you'll get 7.5. So find the average. Add the two numbers and divide by 2. Okay, I'm going to assume that you remember, but you can write that down as well if you forgot how to find the average. Add the two numbers and divide by 2. Okay, so that idea is actually going to translate really well to what we're going to do in a few seconds, because we are now trying to find the midpoint between 2 points. Midpoint of a line segment. So the line segment is defined by the endpoints AB here. So -4, 2, and 6, 2. So let me just write it down. Okay, let's plot those two. -4, 2. That's A. 6, 2. That's B. Okay. I don't have my ruler here with me, so. All right. It's good enough for me. Okay. I'm not going to plot the endpoints for my next line segment. I'm just going to tackle this one. So this line segment AB is actually very friendly because it's a horizontal line. So in fact, you can just think of, ignore the Cartesian plane. Just think of this as a number line, right? -4 and 6. You have to average -4 and 6. So -4 plus 6 is 2. 2 divided by 2 is 1. It's right here, right? Look, think about it. If you're here, you're 5 units away from B, and you're 5 units away from A. Yeah, that's right here. That's the midpoint of AB. So midpoint of AB what was it? 2. Oops. 1, 2, not 2, 1. 1, 2. Okay. So that's why we previously were talking about averaging between two numbers. Okay. Let's try 3, 0, and 2, 0. So -3, 0 is right here. 2, 0 is right here. Okay. So this one, once again, imagine the coordinate plane is gone, so really you're just working with a number line, you can imagine. So -3 and 2, average those two values. -3 is, -3 plus 2 is -1, so that's -1/2 when you divide by 2. Let's check. Ooh, beautiful. You're 2.5 units away from C, 2.5 units away from D. Beautiful. So this is midpoint of CD right there. Therefore, the midpoint of CD is -1/2, 0. Okay, let's keep going. So, -4, 2, -4, -6. Let's indicate the scale first. -4, 2, and -4, -6. 3. Hey, this line segment is not horizontal, but it's vertical. Okay, so midpoint of AB. Imagine your number line is now rotated, so it's vertical. So you want to average between 2 and -6, right? Average between 2 and -6. So this time we're working with the y coordinates as opposed to x coordinates. I think it was more intuitive beforehand, but I mean this one's not that bad. So average between 2 and -6. So 2 plus -6 is -4. -4 divided by 2 is -2. It's very visual. Let's check. How many units are away from A, endpoint A? 4. And 4. Beautiful. So you're 4 away from A, 4 away from B. So I'm very confident that is indeed the midpoint of AB. -4, -2. Bam, beautiful. Okay, so let's do C here. -1, 7. Oh, that's ugly. Okay, let's check. 3, 6, 7. Yep. -1, -2. Okay, what's the midpoint of CD? Let's average 7 and -2. That's going to be 2.5. So once again, you'll work with a y coordinate as opposed to the x coordinates. Let's check. This is 4.5. This is 4.5. Beautiful. Let's see. What was it? -1, 2.5. Okay. In your own words, define what is the midpoint of a line segment. So I really wish you were to use your own wording to answer these questions so it's more meaningful to you. But I said it quite a few times, but I'll say it again, or I'll write it again. What is the midpoint of a line segment? It is the point on the line segment is equidistant. Equidistant is just a fancy word for distance too. Equidistant to both endpoints. It is the point on the line segment which is equidistant to both endpoints. So you don't need to, really memorize the fancy wording. Really, you can visualize what a midpoint is. Okay, or midpoint of a line segment. Okay, so there's one big drawback. I want you to take a look at what we've done here. There's one big drawback with what we're trying to do. Remember, the big goal here is to find the midpoint of a line segment. There's a problem, okay? Hopefully you've noticed that the problem is the fact that on the first two questions, we focus on line segments which are horizontal. And then we focus on line segments which are vertical. Well, to be honest with you, most of the line segments I'm going to work with in this course are neither vertical nor horizontal. They're going to be slanted. Okay, so how do we find the midpoint of a line segment which is not horizontal or vertical? So what I'm going to try to do is prove the midpoint formula. So what I'm going to do is I won't introduce the coordinate plane yet. I'm just going to draw the line segment and then I'm going to put it on the coordinate plane. So let's just draw this line segment. So let's call this A and let's call this B. Beautiful line segment. Okay. So what I would do here is I'm going to say this is the midpoint. All right. Now I'm going to do something we learned in grade 9 math. So when you have 2 points and you found the slope, let's say you want to find the slope from the midpoint, like if I would just hide this, if you were to find the slope, you would draw a right triangle. So you can show yourself the rise and show yourself the run. So I'm going to do the exact same thing. Okay, beautiful. So you know what? I really want to prove to you that these two triangles are congruent. Okay, I'll get to why I want to prove that to you, but I really want to prove that these two triangles are the same shape and the same size. Okay, so hopefully you remember the word congruent from elementary school. So if this is the midpoint, guess what I can conclude? That of course it's equidistant to A as well as B. Okay, so these two distances are the same. And now I'm going to try to prove to you that this angle is congruent to this angle. So I don't want to add too much, but I'm hoping you can see there's an F pattern here. Okay, these two, of course, are parallel, right? This is horizontal and this is horizontal. So if that is the case, I'm hoping you can see this angle here is congruent to this angle here. So let's add that. Let's add that because they're congruent. And then guess what? If this is congruent with this and these are both 90-degree angles, can you not say this angle is the same as this angle? So I know we haven't proven or learned how to prove whether two triangles are congruent or not, but I have way more than sufficient information to prove that these two triangles are indeed congruent. Okay, so I'm going to teach you how to prove congruence later on, and I hate to say wait, but just wait or just take my word for now, and let's agree that these two triangles are congruent. So if I've proven that these two triangles are congruent, then I can actually use that fact to help me get to the midpoint formula of a line segment. Okay, so I don't know if it's too messy for you. Hopefully it's not. I'm just gonna draw the axes now. So let's say point A is x1, y1, okay, and let's say point B is x2, y2. Okay, now if these two triangles are congruent, of course this length is the same as this length, okay, and this length here is the same as this length here. So believe it or not, that really helps me find the midpoint formula, because let's start with the x-coordinate, because I think you're better at thinking horizontally. I'm going to start with the x-coordinate. What's the x-coordinate of the midpoint? Well, the x-coordinate of the midpoint, you have, since this is the same as this, right, these lengths are the same, then I have to average the x-coordinates to find the middle of the x. Okay, so you have to average the x-coordinates to find the x-coordinate of the midpoint. And how do you find the y-coordinate of the midpoint? You have to remember, because this length is the same as this length, to find the y-coordinate of the midpoint, guess what? You have to average the y-coordinates too, right? To find the halfway point, you have to average the y-coordinates. So there you go. If that was a little too much, just really slow it down. It really helps to understand that they are congruent triangles. Once you see that they're congruent triangles, this relationship of finding halfway between the x coordinates and halfway between the y coordinates, it really helps, because then you're able to find that midpoint. If it helps, I don't know if you can also draw a bigger triangle. Okay, find a bigger triangle, and then you can see really it's the halfway point, right? You can find this is the you can shift this this point over here, and you'll see that if you want to get to a point on this horizontal line, you need to average the y-coordinates. And if you want to get to a point on this vertical line, you have to average the x-coordinates. And if you want exactly the midpoint of the line segment, you average the x and the y-coordinates. So just really stare at the diagram for a few good minutes, and it will be pretty obvious that it makes perfect sense to average the x values and average the y values. But it all is based on the fact that these two triangles are congruent, and it makes sense. It really makes sense that they're congruent. Okay, so let's use the formula and do the work. So the midpoint of AB. The textbook's formatting is a little different, but this is just the notation I use. So the midpoint of AB is equal to, you know what? I'm going to write down the formula since we just learned it. Oops. And I got it wrong already. You want to average the x values, average the y values. Okay, so 1 plus 3, 1 plus 3. So the midpoint of AB is 2, 2. Okay, let's try the midpoint of CD. Average the x-coordinates to find the x-coordinate of the midpoint. Let's average the y-coordinates to find the y-coordinates of the midpoint. So really think averaging finds the middle. Averaging finds a halfway point, and that would really help you remember the midpoint formula. Okay, and sometimes we give you a little twist to this question. We give you one of the endpoints and the midpoint of the line segment, and your job is to find the other endpoint. So let's break it down. So if I average x with 8, if I average the x-coordinate of D with 8, I get 4. Hey, what do you know? I have an equation which I can solve this. I can solve for the x-coordinate. All right, interesting. The x-coordinate of the other endpoint is D. Okay, let's do this same logic for y. So y coordinate of the endpoint plus the 7. If I average that, I get 2. So okay, multiply both sides by 2 and negative 3. Bam. So guess what? Therefore, D has coordinates of 0, negative 3. So that's the lesson for today. The big goal here is just to find the midpoint of a line segment. So we start off with horizontal, well, we first start off with just how to find halfway between two numbers, and then we talked about horizontal line segments, vertical line segments, and then what it means to be the midpoint of a line segment. And then we use congruent triangles to really emphasize or prove how we got to the midpoint formula.